Hey everyone, trying out a new format this morning, but I just wanted to do a quick video on my top 5 things that I think all programmers should learn when they're just starting out. So I'm not talking about languages or operating systems or IDEs or anything like that, because realistically, that's a whole big discussion. We can do that in another video, but I think these are 5 things that apply to just about any situation you might go into. So it doesn't matter whether you're doing mobile development, web development, desktop development, JavaScript, C#, doesn't matter. These are 5 kind of fundamental concepts that are not super theoretical, that you're actually going to put into practice day in, day out as a developer. And just starting out, these are kind of the most important things to start out doing, get familiar with, so that you can be successful in your job or whatever you're doing programming for. But before we get into it, I'd like to invite you to like this video if you like the content, if you like the channel. Consider subscribing. I'm going to try to do more like this on a more regular basis. I know I've been saying that for the last few months, and unfortunately life has just gotten in the way. But this is a really easy format for me to do. I'm going to try to do this, I'm going to say every morning. Hopefully it'll be, at least once a week, but I'm going to try to do it every morning. We'll see. We'll try to do it at least every morning this week and see how it goes. So hopefully you like this, and again, give the thumbs up, subscribe to the channel, hit that notification bell, and share this with your friends, share this with your colleagues, share this with people just trying to break into an industry. I'm really trying to gear this toward people at all skill levels, but also make it accessible to people who are just starting out. And this video especially is really geared toward people just starting out. So without further ado, let's get into it. So the first thing that I think is absolutely the most important thing for anyone at all skill levels to get better at doing is reading code. And I actually have a whole video on this. I'll leave a link down in the description below. But reading code, being able to read both your code that you've written before, other people's code on Stack Overflow, it's immensely important. I'd say 90% of what we do as developers is reading code, and that's super important. A super important skill to refine and hone, and even I'm still getting better at it. I constantly run into situations where there's code that doesn't make any sense to me, and I have to kind of stop and think it through. Whereas, there's also plenty of code that I've seen before that I can kind of pick up, at a moment's notice. Stack Overflow articles or Stack Overflow answers tend to be a little bit easier for me just because I've done it so much. But reading code is a skill that will pay dividends beyond anything else. It's a skill you'll constantly refine, and it's by far the most important thing you can do as a programmer. Second thing is debugging. So if I said 90% of the time we're reading code, out of the other 10%, 9 of that percent is debugging. And by debugging, I'm talking stepping through code, basically determining, does this code do what I think it does? I already read the code. I think it does one thing. Does it actually do that? And this might be, it's called debugging, right? It might be for us to be able to find a bug, but it might just be for us to understand the code and know what's going on and see deeper into, some of the data structures that are being passed around. But debugging really is a very important skill, and I mean this both from the IDE perspective of like setting breakpoints and then stepping through from there, and also putting console log or console.writeline or printf statements if you're doing C, anything that writes to the console or writes to a log. The kind of the old school debugging before we had really good debuggers that supported setting breakpoints and that sort of thing. Okay, so number 3 is data structures. And the reason I think data structures are important, you'll hear stories of interviews at places like Amazon and Google and Facebook, all those big companies, where they really focus on data structures. Yeah, sure, learning data structures will help you with those interviews, sure. But realistically, learning data structures helps you think more broadly about how to organize data in your programs and how to link data together, because a lot of what we do as programmers is taking data from one place, manipulating it in some way, and putting it in a different place. That's a gross oversimplification, but in order to do that efficiently and keep track of the data that correlates to other data that we're dealing with, using data structures is what we're going to be doing all the time. So data structures are key. There are lots of good resources on data structures, but some important ones to think about are things like linked lists and maps, including hash maps, trees, graphs. That's kind of the quick, short overview. Obviously, there are many more: queues, that sort of thing, stacks. But start small, and you can gradually get up to trees and graphs. Those get a little more advanced, and there's a lot of, you can get really involved in them if you want to, if you find them exciting. And then 4 and 5 really go together. 4 and 5 really go together, but I think they are distinct things to really focus on. One is code organization, and what I mean by that is if you're dealing with an object-oriented language, things like what code belongs with which object, which method or member function should be responsible for what things, should they be responsible for updating the object or just getting information about the object, computing values from the object's state, and really managing that delineation of what belongs in this object, what belongs in that object, what is this object's state, and what is this object's actions, or maybe should we have a separate set of code that is kind of like helper functions. That logic doesn't necessarily belong inside the object, it belongs more in in its own file somewhere. All decisions that even I'm still making bad decisions when it comes to this. But what happens is I make the best decision based on what I'm dealing with at the time, and then I can always go back and fix it, which segues into number 5, which is refactoring. Refactoring is one of the harder skills, but definitely one that will bring you really far, because what will always happen is we'll write code based on the requirements that we have and that we can anticipate. And that anticipation aspect sometimes can get us into trouble. You can definitely prematurely optimize, you can over-engineer. So you want to strike a balance. You obviously want to address the requirements that you have right now, but you also want to not paint yourself in a corner, or at least I try to avoid painting myself into a corner. And this is definitely something that comes with experience, knowing what looks more like painting yourself into a corner versus other things. So that said, you'll always get into a situation later on down the road where there's a new requirement that you didn't necessarily anticipate, or you thought you anticipated it, but it turns out that it's a little bit different from what you anticipated. So you have to change how the code operates. And in some cases, this means changing the structure of the code. Now, refactoring as a term is writing, what is it? Martin Fowler has a really good definition, and I hope I can do it justice. It's basically writing code without changing how the function, how the code functionally works. So you make a change that maybe changes the name of a function, or extracts common functionality from one function into its own function, and then maybe you're calling it from 2 different places. So the code does the same thing, it performs the same logic, but you have made changes to the code. So it's making changes to the code without any functional changes to the inputs and outputs. So refactoring is key as systems grow and grow, and as you start adding more and more features to them, because ultimately you don't want to end up repeating yourself. There's an acronym out there, DRY, don't repeat yourself. It's okay to repeat yourself, if you're doing the same thing in two places and you're not entirely sure how to refactor, especially when you're just starting out. If the easiest way to get something done is to copy and paste, go ahead, copy paste. Start with copy paste. Once you copy paste, then you can look at the two versions next to each other and start to see similarities and start to see which pieces you can extract out into their own functions. Some IDEs even have like helper routines, macros, that sort of thing, where you can select a bunch of code and say refactor into its own method. The JetBrains suite of tools is really good about that. I could go on and on about refactoring, and I think the birds are telling me that I need to shut up and close out the video. So with that, those are my top 5 things to get started with that are really important to learn and get better at as a developer just starting out. Reading code, debugging, learning data structures, code organization, and refactoring. If you have something that you think is really important that I missed from this list, go ahead and leave a comment down below. Let's start a discussion down there. If you have any questions on this that you want me to do a future video on, or any future topics, go ahead and leave a comment down below. Like I said, I'm going to try to do this a lot more frequently, just me sitting talking to the camera about various topics in programming. So go ahead and leave a comment down below with some ideas that you want to see, and I'll do them in the next couple weeks. Thanks for watching. I'll see you hopefully tomorrow.